Assalamu alaikum. This is titled How Beginners Get It Wrong in Machine Learning. My name is Abderrahman Jaize and I am a data scientist. So my talk will be focusing on the 5 most common mistakes that beginners make and how to avoid them. I will try my best to give some good common mistakes, and then we'll start with that. I do help beginners get started in machine learning, but I see the same mistakes in both mindset and action again and again. In this presentation, you will discover the 5 most common ways that I see beginners slip up when getting started in machine learning. I firmly believe that anyone can get started and do really well with applied machine learning. Hopefully, you can identify yourself in this presentation and take some corrective actions to get back on course. So let's get started. So, do you want to learn machine learning? Easily. You will work hard to learn the background in math, and then find yourself in need to understand how theory works, the theory of machine learning, of theory of algorithms of machine learning. After that, you will have to implement algorithms from scratch. Then the magic happens. You start understanding how machine learning works and how to implement them and how to work with them. So finally, you will start using machine learning as your subjective goal. This approach is slow and it's hard. It's designed for academics that want to extend the state of the art. It is not designed for practitioners that want a result. In my opinion, and I want to emphasize on that, my opinion, my only opinion, the best way to approach and to teach machine learning should be bottom up. So if you want to look at it from the bottom line, then you should start using machine learning first. This is your goal, but start with it. Start using machine learning. Then the magic will happen. But this time, the magic will not happen like you did understand that. The magic is you will fall in love with the machine learning, how it works, why we do it, and how we can use it in our daily life. So after that, all you have to do is start implementing algorithms that will come as fast as your instinct. You will start implementing those algorithms from scratch. After that, all you have to do is understand the theory of the machine learning algorithms. That's like a chain. Once you understand, you want to understand the theory of the machine learning, easily you will fall back in love with the math of it and understand how really it works. It's like a chain, and every piece of the chain is connected to another one, and you do have one in order to understand the other one. In general, all you have to do is like start from somewhere and then you will get some to the other place. But the traditional approach is from the top to the bottom. But what I suggest is start from the bottom to the top. So the first thing first, or we can say the first mistake, or the first trap. Don't start with theory. You know you are caught in this trap if you think or say things like, I need to complete this course in linear algebra before I start doing this. No. Before you can become a data scientist, you have to implement things. You have to try out things. So you don't need to wait for these things to happen before. You don't need to understand like algorithms and stuff before doing it. So again, you are in this trap if you think or say things like, I need to go back and get a PhD first. I have to read this textbook first. The same thing happens to me before I started this. Before I become a good data scientist, I needed, and I've fallen in this trap. So I had to change this mindset. How did I do that? So the way out of this, think of it like, how does learning 4 years of math or historic algorithms, like historic algorithms theory, get you to where you want to be? You are more likely to stop, to fail, or to not get any closer to your goal. The solution is to flip the model. This is easy. If the valuable contribution of machine learning to the market is the set of accurate predictions, then learn how to model problems and make accurate predictions. Start from this place, from here. Then get really good, damn good at it. Be good. Start read what you can find on the internet. Steal whatever code you can find. Harness the theory if you need it, but only in service of your goal. Only if it makes you better at delivering value. Secondly, don't study all the machine learning. In general, machine learning is a very large field of study. It is the automation of learning processes with computer and has deep overlap with artificial intelligence. From historic learning theory to robotics, the field is very massive and very big. If you want to look at it in a way, the field is way too big for you to take on all of it. So, you've stumbled into this trap if you think like, I need to learn about each new technique mentioned on a new website. I need to learn about computer vision, natural language processing, speech, etc. I need to know everything about everything. That's the trap. You don't have to. So all I'm asking you to do is try and not fall in these kind of things. So how do we get out of this? Pick one small corner and focus on it. Then narrow it down. After you narrow it down, if you say it as the most valuable area of machine learning is predictive modeling, creating models from data to make predictions. Start there. Next, focus on a type of predictive modeling that is most relevant or interesting to you. Then stick with it. Maybe you choose by technique, such as deep learning, or maybe choose by problem type, such as recommender system. Maybe you're not sure, so just pick one anyway. Get good, or at the very least proficient. Then later, circle back to another area. So the third thing you should focus on. Machine learning is really about the algorithms. There are a lot of algorithms, and each algorithm is a complex system on its own. Algorithms are have such complexity concepts that they are their own ecosystem. You can lose yourself in an algorithm, and people do, and we call them academics. So you're in this trap if you find yourself saying, I need to know why it works before I use it. I need to deeply understand the hyperparameters first, and I need to explain the cause and effects when tuning. This is one of the biggest problems that I had to fight when I started learning machine learning. So the fact that you don't know about a lot of algorithms makes you push yourself to stop learning about them and implementing them and using them as needed, because just you don't know how they work, or because you don't deeply understand how these scripts function. And this is one of the biggest and major drawbacks in machine learning. That's why people drop out of machine learning. That's why people don't keep up when new things come up, when they have to understand better things like this. So the way out: always know that algorithms are not results. They are a mean to a result. In fact, machine learning algorithms are a commodity. Swipe them out. Try out a ton of them on your problems. Tune them, but move on. You can learn more about algorithms to get a better result. You can. It's easily done. but know when to stop. I can give an advice, but it wouldn't help. In my case, I used a systematic process. I was designing, tuning experiments, and automating their execution and analysis. That easily done. But machine learning is all about good use of algorithms. But applied machine learning it's not just fiddling with algorithms. You have to focus on your goal. So if your goal was delivering result from each project, then it's a set of predictions or a model that can make this happen. The fourth thing, don't implement everything from scratch. You can learn a lot from implementing algorithms from scratch. But sometimes you even need to implement techniques because they are not suitable or available implementation. But generally, you don't have to, and you shouldn't. Your implementation will probably suck. I am sorry, but it will have bugs. It will be slow. Sometimes it will be a memory hog. In a lot of cases, it will not deal with edge cases very well, and it might even be wrong. So you're in this trap if you're writing code to load a CSV file, I mean. You're writing code for a standard algorithms like linear regression, or you're writing code for cross-validation or hyperparameters tuning. This is a bad thing. Most of the new users of machine learning or new users of the algorithms that exist, they fall into this trap. And this is one of the most crucial traps that a data scientist or someone who wants to learn machine learning will fall in. You don't have to reinvent the wheel. It's already there. So all you have to do is use it. In my case, when I first started this, I have been reading code from scratch. I did really write codes to load a CSV file. I didn't know that it's not good. I didn't know it's the trap. So it takes a lot of time, and you eventually find out that it's not that's very proficient. That's not the way it should work. You will find yourself wasting 2 to 3 hours just working on something that already exists. And even if what you made works, you will find bugs in it. You did not take in consideration a lot of cases, some exceptions, a lot of things you will miss out. So the way out of this trap, just stop writing everything from scratch. Do not write something that exists. Use a general purpose library. These kind of libraries are used by tons of hundreds of thousands of other developers. They handled all the edge cases, and it's known to be correct. Try and use these kind of libraries. Use a highly optimized library. That means this highly optimized library squeezes every last cycle and every last byte of memory from your hardware. Use a graphical user interface for your own projects and avoid code altogether in general. So if I wanted to add something to this, implementing everything every time you want to use it is a very slow way to get started in machine learning in general. All you have to do is, if you are implementing for learning, then be honest with yourself and separate that from learning how to deliver value with applied machine learning. The fifth thing, don't change tools all the time. There is a lot of great machine learning tools. In fact, great tools along with data availability and fast hardware is why we are seeing how great machine learning can be. But you can fall into the trap of jumping to each new tool you stumble across. So you're in this trap if you find yourself using each new tool you hear about. You're in this trap if you find yourself learning new tool or language every week or month. You're in this trap if you find yourself get halfway through learning a library and leaving it behind for a new one. So what's the way out from this case? This is like one of the hardest traps to fall in, and at the same time it's an edge with two cases. It may be good if you fall in this trap and may be bad at the same time. So learn and use new tools. No one said don't. But be strategic. That's easy. So all you have to do is integrate new tools into your systematic process for working through machine learning problems. In my opinion, and my advice to you is you will be a lot more efficient in working through problems if you pick one of the large major platforms and stick with it, at least until you are good or professional with it. The top 3 platforms I recommend are like Weka Workbench, Python ecosystem, and R platform. These are like one of the biggest 3 platforms that exists. There are others, and there are more specialty tools if that is your area. Following through is I'm gonna repeat this word like a lot of times. Following through is the difference between a hobbyist and a professional in machine learning. So to give a summary of what I was talking about, in this presentation, you have discovered the 5 most common mistakes that I see, and I want to emphasize on I see. It's my own experience that I see made by beginners in machine learning. Again, they were: don't start with theory, don't study all of machine learning, and don't fiddle around with algorithms. 4, don't implement everything from scratch, and don't change tools all the time. Have you fallen into any of these traps? And do you need like help getting out? Thank you for your assistance, and I'm open to your questions if you have them. أشواق جودة، هل يوجد شهادة على الدورة؟ صراحة ما فهمتش السؤال. بمعنى شهادة على الدورة. Do we give like presentation on this? Will the live be saved? Yes, I think the live will be saved. We work on it. Yes, feel free to ask any question, guys, related to machine learning, or if you are just beginners into this field, I will try my best and give you like the proper answers to them. Okay. Is R programming different from C language? In general, R programming is like for statistical means. It's different in the case, like when we talk about C programming language, it's like a procedural like programming language. When we talk about R, it's the same thing, but for C language, it's dedicated for a lot of uses, but R language is only for like statistical things, like analysis for the data and stuff like this. What did you mean by don't study all ML? What I mean by that is like you don't have to study all machine learning fields. Try and pick one at first because you are beginners. If you are a beginner, you have to start with something small, narrow it as possible as you can, and then start from there, and then learn all in that area, and from that then go circle back to another field. Thank you, man. Thanks a lot. It's really interesting. Hello, thanks so much for this talk. It's really informative and important. Thank you, Abdul Qadir. What's the proper language for beginners? It depends. If there is like two things I can recommend, like you can start with Python because there is like a lot of documentation and people already started working with this, and you can start with R. Also is a good thing to start with. Just started this field. I get a course called machine learning from Coursera, and I don't know what is the next step. I will like I can only say the only way to start in machine learning is to start implementing like algorithms. So start a field, pick a type of problem, and then try and find solution and how they can find solution to those problems, and understand how they model those problems and how they can create like predictive modeling stuff. How can I benefit from your advice to follow the approach bottom up, so that I should use some easy tool like TensorFlow instead of coding ML algorithm using, let's say, Scala and Python? Actually, it depends on how much do you want to try this approach. If you think like you can you will not lose like your interest from the start, like you can understand the math, how it works, and then understand how the theory works, and then start implementing those algorithms from scratch, and then learn how to use machine learning. That's a good approach. But if you want to use my approach, I'm saying that use this approach in case you feel like you cannot follow up with people, because some people can do these steps on this way. In my case, I couldn't, because when I started in this, I did not understand nothing. Nothing was like getting to me. The only way I did understand some stuff is by going from the reverse. I had to implement those, like I had to find a project with already made with TensorFlow, install it, work with it, understand how the project works, the idea, and then I started understanding how did they make that project. So they started with this, and then they did this. After they did that, they had to label those stuff, then they had to process the data. After they process the data, they give it to TensorFlow, they create their model, and then I don't understand how this works eventually, but I know the process, how they do it. Now I understand how it's done. After I understand how TensorFlow can make these things happen, now I can go deeply into TensorFlow and try and understand what makes TensorFlow good and better, and why we should use TensorFlow. So that's it. Now I'm going into TensorFlow and trying to understand all the kind of cases I can use using TensorFlow, and after that I will go deeply into the theoretical part and see, okay, now if I give it this, it should give this. If I give it this, it should give this. And I've given it this. Now I'm finding myself understanding TensorFlow even better with time. But I'm afraid that later on I can go deeper, and maybe you don't have enough spirit to spend the time learning how algorithm works. Actually, you will always find time to understand how algorithms work, because at most of the time you will have errors, bugs, and everything will be like falling apart. And in order to fix those bugs, those little bugs, you have to understand a little bit about how the algorithms works. So if you try a new algorithm, it will not work at first, but once you start doing it a lot, you will fall into bugs. Once you fall into bugs, you will try and fix them. And once you are trying to fix them, you will understand something more about the algorithm, and in this way it keeps going this way. I like the ML field. 2 years ago, I also became master. I'm sad to tell you that I'm still a web developer with no daily life experience. It depends on your motivation. If you want to learn machine learning, you will learn it as soon as it. If like it's like I said, you start using machine learning, you do not understand how it works. Just start using it, and then after this, you will fall in love with machine learning, and altogether it will come. It's like a chain. A piece comes after another piece. Can you advise beginners some courses, website, channels that you worked with? When I started with machine learning, I used the first course that all the data scientists use, and it's like in Coursera. It's Andrew Ng course. It's machine learning with Andrew Ng, and it's one of the greatest courses you can start with. It gives you a bit how things works, and it does not go that deep in order for you to understand everything. So it's very perfect. I'm a Python developer with 5 years of experience, so that you can please guide me if I should start with some ML libraries, Scala, or go to directly to learn about Google ML, easy tools they provide. So again, you should not think about if you will understand it or not. Think about try to learn how to use it. Learn how to use it. Then with time, you will find yourself trying to understand how it works. That's my only advice to you guys. This is what worked for me. You know that a complete model can be trained and tested in a few clicks using TensorFlow, but is that what an engineer should do? If we're talking about an engineer, yes, engineers should only know how to use the tools. That's how I see things. But if you are like going for a data scientist and for like the major roles in machine learning, you will have to understand how things work, because it will not work all the time. Things will not work all the time. Any more questions, guys? I hope you have enjoyed my talk. I think it will be recorded, and it will stay on this channel. So thank you very much for assisting me today, and good luck. Stay safe and do not leave your homes.